There are 3 types of collisions that we are going to be experimenting with in this lab. The 3 types of collisions are listed here: perfectly elastic, inelastic, and perfectly inelastic. In all of these collisions, momentum is always conserved. That means that the sum of the momentum from our objects initially before the collision, sum of P sub I, equals the sum of the momentum of all of our objects after the collision. That's our sum of P sub F. That's the sum of our final momentums after the collision. So again, in a collision, momentum is always conserved no matter the type, but the kinetic energy might not always be conserved. In a perfectly elastic collision, the kinetic energy is always conserved. That means the sum of the kinetic energy of our objects before the collision equals the sum of the kinetic energy of all of our objects after the collision. Remember, the sub I means initial, before collision. The sub F equals final, after the collision. Now, in an inelastic collision, we still have conservation of momentum, but the energy is not conserved. That means the sum of our kinetic energy before the collision does not equal the sum of all of our kinetic energy of our objects after the collision. The symbol here, the equal sign with the slash through it, means does not equal. Okay. And then we have perfectly inelastic collisions. Our momentum, again, is still conserved. Our kinetic energy is not conserved. And in perfectly inelastic collisions, the objects will stick together after the collision, and then they will continue to move after the collision as one combined mass. So again, in the lab, we're going to be experimenting with all 3 of these types of collisions, and we have one pre-lab question about each one of these types of collisions. So to get you started, this one is our 3rd question in the pre-lab, perfectly elastic. Inelastic is our 4th question. Perfectly inelastic is our 5th question. So go ahead and select the type of collision that you want to work on first.